The application uses Blender as an interface to draw any 3D volume you like. The template Blender file is composed by a panel light source that simulates the X-ray emitter directly in front of several orthographic cameras that simulates the detectors. The render engine inside Blender will simulate the rays going parallel, for orthographic cameras or fan-beamed for perspective ones, from the light source to the cameras. Any object put in the middle with the special material present in the template file will act absorbing the light depending on the density. That will form a density image in the camera that will represent the total absorption in the direction of each light ray. That accurately emulates an X-ray picture, hence, all we have to do is to rotate the object or the camera and keep taking X-rays until we have all 180 degrees coverage. With each image, we can assemble sinograms for each row of the image and use any back projections methods, like the inverse radon transform, to reconstruct each slice. Since Blender is a drawing tool, the flexibility is limitless. We can emulate any geometric artifact like imprecision in the center of rotation, detectors geometry, helicoidal paths, etc. Furthermore, we can use the built-in Python system in Blender to emulate behaviors. For instance, to simulate multi-energy systems, we can use the custom properties of each object and set different densities for each camera. We can then generate, for each angle, a different image corresponding to a specific wavelength that will correspond to a specific density in each object. In fact, we can even define emission and absorption curves so that the final image for that camera takes into account the whole spectrum. In order to use the system, we draw any object in the center of the emitter, detector and click in the button in the custom interface to associate the densities for each camera. In this example, we have two cameras simulating a dual energy scan. Here we are drawing a simple monkey head with some internal structures. After the drawing is done, we click the button to scan the object. When the scan is finished, we will have two sets of X-rays, one for each energy. Each set will have images corresponding to an angle defined by the animation timeline of the template Blender file. They will correspond to the angles of the TC machine. With that data we will have all we need to test the reconstruction algorithms, but now we will have the ground truth of the exact object that should be reconstructed.